Hey everybody. So I'm going to just discuss a little bit about motor efficiency right now. This is just fundamentals, just very basics of motor efficiency. So what I've got is an induction motor and it's producing a torque of 53.8 Newton meters. So this is just values I've come up with, just so I'm clear about that. This isn't a specific motor of any type. I'm just coming up with these values just to show some basics on this. So torque of 53.8 Newton meters. The speed of the rotor is 1745 RPM. The VA of this motor is 15,753 and a power factor of 0.8. We need to figure out what from this I can use to figure out what efficiency actually is. So I like to start off by, if I am looking for efficiency, and we usually describe efficiency as a percentage. So what is efficiency? It is my power output divided by my power input times 100. That'll give me, express it as a percentage. This will give me the decimal. This will give me it as a percentage. So right now, as I look at this, you say, well, I don't have a power input. I don't have a power output. So where else do I start? Well, we do have some values in here that I can calculate power, and that's with my torque formula, or sorry, my power formula using the torque and what the speed is. So we know that the power of a motor will be the torque it's developing times the speed of that motor, and the speed of the rotor specifically, divided by, if I'm going to use watts, my constant becomes 9.55. So there, I have power. I'm calculating power right now. So I have a torque of 53.8 times the speed of 1745 divided by 9.55, and the power on my motor should be 9,830.47, watts. So what is fundamental actually with this formula that I've used? Okay, I've got power. P stands for power. Great. What type of power is it? If you think, what does torque? How do I measure torque? Well, if torque is a measurement and my motor is moving, those are actually output. The only way to measure torque is to measure the performance, or what that motor is actually putting out, the energy that it's distributing. So this right here becomes my output power. So there, I have my output power. So now I have to figure out, how do I get input power out of this? Well, if we remember what VA actually represents, okay, this is, we have to be careful because total power is referred to as watts. So we're not going to call this total power. This is the apparent power. And understanding what apparent power is, I always like to describe this as the total energy. The total energy that's present in order to perform my 9,830 watts. So if that's my total energy, I have to be able to use this to get to total power. And there's lots of ways that you may have been shown this. Quite often we use these as our diagrams. This is the apparent power. This is my true power. This is my quadrature power. And my power factor is a relationship of the better make that adjustment before we get too far, is the power divided by the apparent power. So if we understand that S is the total energy, that's my input energy, that's what all of these represent. These are all input values. That's my input watts, input VARs, input VA. So I'm looking for watts, so all I have to do is take my VA, times it by my power factor, and that will be the input power to my motor. So the input power to this motor, if I take 15,753 times 0.8, I end up with 12,603 watts. And this is an input value. So now I have enough information to proceed with my calculation. My power out is my 9,830.47 watts. Again, this is going to be fairly rounded. 12,603 watts. That's my input power. And then I times that by 100. You end up with approximately 78% efficient is the calculation for my motor. So the two fundamental things with anything like this formula is fairly straightforward. We use this piles and piles and piles. It's understanding what VA represents, and it's understanding what this formula is actually calculating. And if you just analyze this, well, if I want to know what power is actually being calculated, do I understand what torque is? Do I understand what I'm referring to when I'm talking about the speed of the rotor? So I hope this has helped, and we'll see you in the next one.